You're not proud of yourself? I know you are. We've seen for box and whisker plot the things we needed and we've seen how to do it. Now, next up is measures of dispersion, which is the second thing. Okay, one by one, we go for it. So measures of dispersion for grouped and ungrouped. So you're now writing, we are looking at the measures of dispersion. All right, now what are the things that we must remember on these measures of dispersion? Well, measures of dispersion are very fine things. Now, the thing of it is, we'll start with the easy ones like range, blah, 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 and then you should then go to the next. Measures of dispersion. So yes, we have the range and we have the IQR. We saw the IQR in the last thing where you just say Q3 minus Q1. It is actually a measure of dispersion, but Q1 and Q3, the quartiles themselves are measures of central tendency or measures of location. So measures of dispersion, what do we have? We start with the range. This is very easy. So we can say here ungrouped, and then we can say here ungrouped. Then of course for the other side we are going to have for grouped. So there we go. Let's go for it. Let's go for it and let's dominate this. This is not hard. I know I need you to get 100 from here. Okay, definitely. Now let's start with what? You said range. Okay, so let's start with the range. Now what is the range? Well, the range is going to be there for ungrouped data, where we say range is going to be the highest value. So it's just going to be highest value. Then you say minus the lowest value. This gives you the range. Okay. Then the next one is going to be the interquartile range. Okay. IQR. This is just going to be saying Q3 minus Q1. So IQR is there for both. Okay, so we can say IQR is just going to be equal to Q3 minus Q1. It is there. It is the same for both grouped and ungrouped. Okay, the IQR. Then we go to the next one now. Okay, it's the same for both. Now we are going to the most important formula, and that is the formula for variance. And variance, just like mean, has two: the sample variance and the population variance, but it's the very same thing. Okay, just a little bit of the symbols change and nothing else. So we are going to say here sample variance. And you know what we use for sample variance? We use S. So S squared. This gives us the sample variance. Just like for sample mean, we had X bar. So for the sample stuff, we use the symbols, the nice symbols, the letters. So how do we get this variance? You need to remember this. It's going to be, for sample, it's 1 over n minus 1. That is outside, the fraction. Okay, 1 over n minus 1. Now inside, you just say the sum of the squares minus the square of the sum over n. So it's going to be, what did we say? The sum of x squared. So you're going to say sum of x squared. So in other words, you're going to get x squared for x1, x squared for x2, x squared for x3, x squared for x4, x squared for x5, x squared for x6. For all your x values, you get their x squared. Then you add all those x squared. Okay, first is the x squared. Then you do the sum. You add this. You add those values. Then you say minus the sum of x. Then you square. Then divide by n. So you're going to subtract from that the solution you get from adding all the x squared. You're going to subtract the sum. This time you get the sum of x's first, then you square that sum, then you divide by how many they are, and this will now lead you to variance squared. Okay, now but when we do the variance, we put an I. Remember that this xi should not change anything from 1 to n. This should not change anything from 1 to n xi. This is just a subscript, but the rest is the same. You square, then you say then you add them together, then you subtract the sum first, then square, then divided by the number of things, and outside you're going to say over 1 over n minus 1. Now what changes when you're now going to grouped? When we're now going to grouped, we don't have an x anymore. Just like we saw for mean, instead of an x, what do you have? W times f. And what is W? Is the class mark or the midpoint. Okay, the midpoint, you multiply it by the frequency. And how do you get the midpoint? Lower class limit plus upper class limit over 2. Okay, how do you get the midpoint? Lower class boundary plus upper class over 2. You're going to get the midpoint or the W, right? And you're going to say W times F, and you say that is going to be your X. So instead of that, I'm now saying sample variance squared for group data is going to be, it's still 1 over n minus 1 outside. You open a break bucket, then it's going to be the summation of W squared and f. F you're not going to square, okay? Just like you squared x, but you squared the w only, and this is going to be from 1 up to n. Then we say that minus, this is going to be the summation of wf, then you square it outside, then you divide by the f, okay? You divide by the things. This is going to give you your what? This is going to give you your variance. And let me tell you a tip. Variance is the only big formula. If you're good at variance, then the rest is going to be easy for you. This is you see, for variance, if you go in your slides, you see two different formulas. The one I'm giving you is the easy one. It's the one you must be able to do. And remember, don't be shocked when they now just come here and put an I and an I here. This I doesn't change anything. They'll come and put WF, then I, then we say from 1 up to n. This doesn't change anything, okay? We'll be just multiplying the midpoint times the frequency, then we sum that thing, then we'll square later. In here, we square the W, then we multiply by F, then we'll sum later. So it's going to be just the difference like that, okay? Now let's put, what about the population variance? This is important. Once you know variance, then the other ones are going to be a walk in the park. Population variance. How do I do this population variance? For ungrouped again, it's going to be sigma squared. What is it going to be now? This is going to be 1 over capital N. Then we say inside is going to be fuming from 1 up to n of xi squared. Then we say minus the summation of x of xi. Okay, then you will now square outside. This is you should do so much practice until you can do it. It's the summation of x squared, but remember it's xi all squared, and we say from 1 up to n. Then we say minus, now it's going to be the summation of xi. Then we say o squared from 1 up to n divided by n now. Okay, this is what happens, and it's going to be the easiest thing ever. Now what about for this? For grouped data now, what is simple is going to be 1 over n. Then what are we going to do now? You can say the summation of, instead of x, what do we do? The summation of w squared f. Okay, is wi squared fi. Then we say it is from 1 up to k. Okay, from 1 up to k. Then we say minus the summation of wi fi from 1 up to k. Then you square outside. Then you divide by the number of things, which is n. And this is important. Okay. This is what we have, and this is going to be what? This is going to give us the variance. For what? For group data and for ungrouped data. For variance, we should be done. And variance was the only dangerous one. Now, if you know variance, then the rest is going to be a walk in the park, because they are just the 4 more to put. And these 4 are very much related. Number 1, or let me go and put them in the next video, right? I'm going to put them in the next video. We just stop here, and then we just go to the next video, and we see the other measures of dispersion that must be known by heart, which are going to make us able to answer any question. You have to know every measure of dispersion by heart, especially variance. It's the difficult one. The rest is a walk in the park. Okay, goodbye for now. See you in the next one.